Hi all, welcome to the second lecture on two-port networks. Here we are going to discuss about network parameters. If you are firstly watching this video before watching introductory video, I strongly recommend to go through introductory video, then come to this lecture. So let's start. Here we are going to discuss about network parameters. Why network parameters? Why it is required? We discussed in the introductory video. So we'll directly go to the network parameters. We discussed there are 5 network parameters we are going to discuss in this lecture series. First one is Z parameter. Those who have some background on electronics or electrical engineering, from the name itself, it's clear. It's also called impedance parameter. Z represents impedance. Or it can be also called as open circuit parameters. Why it is called open circuit parameter, we'll discuss. So before going to set parameters, we know that a two-port network can be represented like this. A two-port network with two terminals at input and two terminals at output. In terminals we are marking as 1 1 dash and output terminal as 2 and 2 dash. So in order to determine these Z parameters, we have to define basic parameters of this network. In input we have input current and input voltage. The voltage across these two terminals. Input terminal is called input voltage. Similarly, we have output voltage and output current. The direction of current in this analysis, what we consider is all the current, either it is input or output, it is towards, it is into the network. In some cases, in our electronic circuit design and in electronic circuit analysis, we might see in many two-port networks, the current is marked as going from the network. That time we have to mark it as negative. If it is going, then we have to mark it as output. If it is coming, that is the positive direction of the current. So positive direction of the current is current coming to the network. Hope this is clear. So here we know what is impedance. Impedance is basically the ratio of voltage to the current. So here how many voltages we have? Here we have two voltages, one input voltage and other output. How many currents we have? Two currents. One is input current, other one is output current. By combining these four, we can determine or we can define another four parameters, which is called Z parameters. Basically the ratio of these elements, that is Z parameters. Z parameters are the impedance parameters, that means the voltage and current ratio parameters. Which voltage and which current? The voltage, input voltage and input current. Similarly output voltage and output current, and other two parameters, output voltage and input current. Similarly input voltage and output current. So these four combinations will give 4 Z parameters. Those all parameters combinedly called as Z parameters. So what we know, Z impedance is the ratio of voltage and current, or we can mark V by I is Z. This all of you know. So we can write this as V is equal to Z I. If we consider this V as vector, Z also as another vector and I also another vector, this is the representation for Z parameter, or this is the expression for Z parameter. Here V vector represents the voltages. How many voltages we have? Two voltages, V1 and V2. Z vector or Z matrix represents these four impedance what we told before. We'll mark it later. Then we have I vector. I vector, how many i's we have? Two i's, I1 and I2. I1, I2. Then what about Z? Z we have 4, so we'll index like this: Z11, Z12, Z21 and Z22. Hope this is clear. So this is Z matrix, this is I matrix and this V matrix. So Z parameters Z11, Z12, Z21 and Z22. From this we can easily write the expression for each. We can write V1 equal to Z11 I1 plus Z12 I2 plus Z12. Hope all of we know the matrix multiplication rule. Similarly, V2 is equal to Z21 I1 and Z22 I2. So Z21 I1 plus Z22 I2. These are the expression for voltage and current in terms of Z parameters. Here all of you know this is a dependent parameters. Voltages are dependent parameters here. This is the left hand side LHS of the equation. So this is a dependent parameter, which is independent parameters here. Current is independent parameters here. How many currents we have? I1 and I2. Two I1 and I2 are considered as independent parameters and V1, V2 are considered as dependent parameters. What is meant by independent parameters and dependent parameters? Dependent parameters are depends on independent parameters. So here in the expression, the voltage V1 is depends on I1 and I2. That's why it is called dependent parameters. So this is one expression for Z parameters. Then next, what is Z11 from here? It's very easy. We written here V1 is equal to Z11 I1 plus Z12 I2. To get Z11 I1, the first term, or we can rewrite here V11 is equal to Z11 I1 plus Z12 I2. To get Z11, this term should be 0. How to make this term 0? Parameters we cannot make 0. That means Z12 we cannot make 0. So other term is I2. I2 should be 0. If I2 is 0, then what will this expression will become? V1 is equal to Z11 I1. From here, we can write V1 by I1 is equal to Z11. When we got this, when I2 equal to 0. What is the meaning of I2 equal to 0? I2 is the secondary current. That means this current is 0. This current is 0 means this port is open circuit. If it is open circuit, no current will flow. So we can call this as open circuit input impedance, because this is the ratio of input voltage and input current. So it is input impedance. This is also called driving point impedance because these inputs and outputs are the driving points of this network. So these inputs and outputs we are calling driving points. So this input impedance Z11 is also called driving point impedance. Similarly, Z22 also we can derive same way. Z22 will be equal to V2 by I2 provided I1 is equal to 0. Z22 also called driving point impedance. This is output driving point impedance. Similarly, we have other parameters. Z12 we can define in same way. We can get it as V1 by I2. We can see the order. First in numerator it will become first one, denominator it will become second one. So it is easy to remember. Similarly, Z21 is equal to V2 divided by I1. Always that means it will be a ratio of voltage and current, voltage to current. So it's easy to remember all this expression and the condition to get this. This is, we cannot write V1 by I2. We have to write the condition here and here, which should be opened. So here in this term, I2 is there, so I1 should be 0. Similarly for here, I1 is there, so I2 should be 0. So here all the cases, some of the currents are 0. That's why it is called open circuit parameters. Similarly, we can get expression for Y parameters. To get expression for Y parameters, there we have to short any of the terminals. So that's why that is called short circuit parameters. The Y parameters or admittance parameters are called short circuit parameters. Z parameters are called open circuit parameters. So now let us go to the second type of parameters, that is Y parameters. Similarly, we know what is Y. This is admittance. So this is called admittance parameters. And this is also called short circuit parameters. Hope it is clear why it is called short circuit. Same point what we discussed here for open circuit parameter. Similar point is applicable for short circuit parameters also. So this also we can write admittance. What we know what is admittance. Admittance is equal to, is the ratio of current to voltage. Voltage to current ratio is called impedance, and the inverse of that, current to voltage, is called admittance. So we can write admittance as the ratio of current to voltage. So we can write I is equal to YV. If you write in matrix form, we can write it as I1, I2 equal to the Y parameters. We know how it can be written. It can be written Y11, Y12, Y21, Y22. Similarly, here V1 and V2, and this should be closed. Hope you can. I have difficulty to close here in the screen. Hope you can close this. So we can similarly write the expression I1 is equal to Y11 V1. Hope all of you know the matrix multiplication. Otherwise, you just to revise it. Then Y12 V2. This is the expression. So how to find Y11? It's very easy. We have to make this term 0. Parameters we cannot make 0. So what we can make 0 here? V2 is 0. So what we can write is Y11 is equal to I1 by V1 provided V2 is equal to 0. What is the meaning of V2 is equal to 0? V2 is equal to 0 means we have to make the output impedance to 0. How to make an voltage 0? Just short circuit. So if you short circuit this, the voltage at this point will become 0. So if the Y11 is called input impedance or short circuit input impedance, or we can, sorry, not impedance, short circuit input admittance. We can call it as driving point admittance as well. Driving point input admittance, because the already we discussed the input and output terminals through which only we are driving the network. That's why it's called driving point network. Driving means we are giving the signal or we are taking the signal. So that's why it is called driving point impedances. All these terms, please note, because this for diploma level exams, these names and all may come as questions. Now, one more general thing. So hope it is clear what is the Y parameters. Similarly, we can write all these parameters Y12, Y21 and Y22. Hope you can easily write. Already we told Y means the ratio of I by V. First write I by V, or first this right, then this 1 2 means 1 here, 2 here, 2 1 means 2 top, 1 here, 2 2 means 2 here, 2 here. So these are the parameters, and what should be 0 we already know. Here this is admittance parameter, so voltage will be 0. So here V2 already there, so V1 will be 0. Here V2 is V1 is there, so V2 will be 0. Here V2 is there, so V1 will be 0. So these are the conditions, easy to remember. Now one more point here. We know this 1 1 Y11 means driving point impedance. Similarly, Z11 is driving point, sorry, Y11 is driving point admittance and Z11 is driving point impedance. Same, Z22 and Y22, these all are driving point impedance and admittances. Similarly, what is called 1 2? 1 2 means 1 is input, 2 is output. So this is a transfer from input. This is called transfer parameters. So what are transfer parameters? Z12, Z21, similarly Y12, Y21. All are the transfer from input to output, output to input, then this from input to output, then output to input. Usually the output to input is the transfer parameters. If it is reverse, input to output, then we will call it as sometimes reverse transfer parameters. That means this is input to output, this also input to output, 1 2. So this is reverse transfer parameters. This is simply we'll call it as transfer parameters, output to input. Usually we'll call for transfer, this easily you can remember, because for transfer function we'll remember it as output by input ratio. So output by input means it is normal transfer parameters. If it is reverse, then it is called reverse transfer parameters. So what we can call here, Z12 will be equal to, this is Z parameters, so voltage by current 1 2. So this is reverse impedance transfer or reverse transfer impedance or inverse transfer impedance. It is called inverse transfer impedance. The term it is clear, I hope. Sorry, I used the term inverse. The correct term is reverse transfer. So Z12 is called reverse transfer impedance. Similarly, Z21 is called forward transfer impedance. Simply transfer impedance or forward. More accurate term is forward transfer impedance for Z12. So these terms we have to, the names of these terms we have to understand. For some exams this also may come as questions, especially for diploma level exams. So what we discussed is Z11 already we discussed. Similarly, Z11 is called input impedance, Z12 is called reverse transfer impedance. Impedance, this is input impedance. Similarly, Z21 is forward. When it will become forward already we discussed. If it is output by input 2 1, then it is forward. Same thing, transfer impedance. I'm not writing completely, you can fill it easily. Then Z22 is called output impedance. Similarly for admittance also, I think I no need to write it again. Admittance also, Y11 is called input admittance. Similarly for all other Y parameters. Hope this term is clear. We already discussed about transfer parameters and transfer function as also we are deriving from here. What is the impedance transfer function? Impedance transfer function, this is impedances. So impedance are depends on the frequency, all of you know. So you can write transfer functions Z21 is equal to V2S divided by I2S. This S represents the Laplace transform. So Laplace S means it's a frequency dependent term. So just for this is just for understanding, please note it. So Z21 S is called impedance transfer function. Similarly, admittance transfer functions also we can write. Okay, that's all about Z and Y parameters. One more thing we can discuss here. We told in terms of metrics we can write V as Zi. Is right. This is the Z parameter expression in terms of matrix. Here V, Z, I all are matrix. One question, can we write V is equal to IZ? Is both these two are equal? The answer is no. Remember that these are our matrices. Matrix multiplication is not commutative. You can call it as commutative. But generally, matrix AB is not equal to matrix BA. This property is not applicable for matrix multiplication. So the matrix multiplication Zi not equal to iz. So we cannot write. From this also we can frame questions. Why I'm not highlighting this point is from this all we can make some questions for some exams. So please note this point. We know, right, in order to multiply v is a matrix with two rows and one column, so we can write it as 2 by 1 matrix, and z is 2 by 2 matrix, and I is 1 by 2, sorry, 2 by 1 matrix. I and V are 2 by 1 matrix. So in order to multiply two matrices, this is one matrix and this is one matrix, this is another matrix. The column of first matrix should be equal to the number of rows of other matrix. These two should be equal, then only matrix multiplication is possible. Here if you write reverse way, 2 by 1, here you can see how to find the resultant matrix dimension. If you are already, we studied this in our mathematics matrix class, just I'm recapping here. If you already know, you can skip this section. So to get the output dimension, this will be the, if you are removing the common dimension or common number of elements, the resultant will be the output of this matrix. Similarly, if you are reversing, what will happen? 2 by 1 multiplied with 2 by 2, it's not possible because these two are not equal. Since these two are not equal, the number of columns of this matrix is not equal to number of rows of this matrix. The matrix multiplication is not possible. So this is just a hint about the matrix multiplication. So similarly, this connected questions we can ask. Similarly, is y, we know y is admittance, y we know the ratio of current by voltage, and impedance is the ratio of voltage by current. Can we write y is equal to 1 by z? No, this also wrong. Y is the z inverse of z is a matrix. Always remember, z is a matrix. So for a matrix, it is not 1 by z, it is a z inverse. We have to find the inverse of the matrix, then that will be equal to the y matrix. But y is not is equal to 1 by z. In terms of matrix, 1 by z not is equal to z inverse. Please remember these points. Next, let us move to other important parameters, ABCD parameters. ABCD parameters are also called transmission parameters. From the name itself, it is clear. It is describing about the transmission. Transmission means from input to output or from output to input. Previously, the parameters V1, V2, if it is Z parameters, we have written like this, V1, V2. And in ABCD parameters or in transmission parameters, how it is differ is the voltage V and I2. This we are going to write in terms of V1, V2 and I1.